Now sometime we may have situation where instead of the plane surface we may have a curved surface. As we know that fluid, whether it may be liquid, it may be gases, need to be stored. In many engineering applications, we need to store natural gas, we need to store LPG, we need to store the crude oil, etc. For that, sometime we may have the curved surface. So if we have a curved surface, in that case, the direction of the force is continuously changing because of one reason, that when fluid is in contact with the surface, in that case the force must be acting in such a manner so that it is perpendicular to that point. Then only it will have no tangential component. If it is having an tangential component, that we know that shear stress will act and fluid will start flowing. So to avoid that, or basically it is the principle that under static condition force must be perpendicular. So that's why in a curved surface the direction of the force is continuously changing. So to calculate what is the force exerted by the fluid on curved surface, what we do, just look at this figure. In this figure we have a liquid and this is the solids contact. Here what we do, we take a free body diagram of the liquid A, B, C and A. This is represented by these dashed lines. In this figure, this one is the horizontal projection of projected area and this one is the perpendicular projection of the area. Now if we draw the free body diagram of this one, which is shown in this figure, here in this figure this top surface, which is the horizontal projected area of the curved surface, will be experiencing force, and that magnitude can be calculated by simple principle which we have just discussed. What is the force acting on this surface is equal to this height multiplied by gamma, weight density of fluid, multiplied by this projected area AB and multiplied by perpendicular distance, perpendicular to this plane, perpendicular to AB. That will be the force Fy. And what is the force on this perpendicular surface? In perpendicular surface we have just discussed, for inclined surface when theta becomes 90 degree, we can calculate this force. In this case, this pressure force from B to C is continuously changing, it is increasing here because height is continuously going up. When height is going up, then pressure will keep going up and we can get the resultant force and its point of application with the help of just discussed principles and formulas. And once we know this F x and Fy, we can find out, since this fluid element is in stable static equilibrium condition, so we can get this horizontal component and vertical component. This horizontal component will be same as this Fx, so Fh is equal to Fx, and Fv is equal to this force Fy plus this weight of the liquid. So Fv, vertical force, is equal to Fy plus weight of the liquid. So by using this concept we can find out the horizontal component of force on curved surface and vertical component of force on curved surface, and this Fy plus W is a vectorial summation, and we can get the resultant force with the simple principle. It is root of Fh square plus Fv square, and as far as angle is concerned, that angle is equal to Fv divided by Fh. So with the help of this principle of free body diagram, we can get the force on curved surface by taking the projection of that curved surface in horizontal plane and vertical plane, and with the help of those forces on the plane surface, because horizontal projection will be plane surface and vertical projection will be also plane surface. So after getting the force on plane surface, we can find out the force acting on horizontal direction and vertical direction on the curved surface.